or a strip in paper chromatography, not strip in paper chromatography. The different spots can be recognized by or identified by number one, either by their characteristic color, by their color. Number two, by placing in a UV chamber, Number three, by spraying iodine. Number four, for amino acids, by spraying ninhydrin. So write the next heading, qualitative analysis of organic compounds. Qualitative analysis of organic compounds. In that, write the first subheading, detection of carbon and hydrogen. Detection of C and H. Carbon and hydrogen detection. The given sample is heated with cupric oxide. If the sample contains carbon, it reacts like so C plus 2Cu plus CO2. So when you heat the given sample with the cupric oxide, if at all the sample contains carbon, it is oxidized to carbon dioxide. This CO2 turns lime water milky. This is lime water. The milkiness is due to the formation of calcium carbonate, that is white in color, milky, plus H2. So very simple. Whenever you want to detect carbon, the given sample is heated with what? Cupric oxide. The carbon is oxidized to carbon dioxide. Carbon dioxide is easily detected by turning the lime water into milkiness. Next, if the sample contains hydrogen, two H atoms, here I am writing, two hydrogen atoms react with cupric oxide to form copper plus H2O. This water vapor is absorbed in anhydrous cupric sulfate, which is colorless. So this colorless cupric sulfate, when exposed to the water vapor, it reacts with 5 water molecules, forming CuSO4, 5H2O, which is blue in color. So this is detection of carbon and hydrogen. So carbon and hydrogen, how they are detected? By heating with cupric oxide. Carbon is converted into carbon dioxide, hydrogen is converted into water vapor. How you can recognize the water vapor? By absorbing in anhydrous cupric sulfate, which is colorless. So the colorless cupric sulfate, when it turns into blue color due to the formation of a pentahydrate, cupric sulfate pentahydrate, then you say water molecules are there, then the sample contains hydrogen. Next subheading, detection of nitrogen, sulfur, phosphorus and halogens. Detection of N, nitrogen, sulfur, nitrogen, sulfur, phosphorus and halogens. Next point, in this heading, N, S and halogens. N, S, sulfur and halogens are detected by Lessein's test. In Lessein's test, you have to make first Lessein's extract. So we have to prepare Lessein's extract or sodium fusion extract. So given sample plus sodium metal fuse means melt. Fuse or melt. So you'll get a molten mass or fused mass. This is mixed in water and you will get a solution. This solution is boiled and filtered. The filtrate is known as the filtrate is known as Lessein's extract. So in a flow chart, so 3 steps. The given sample plus sodium, you are fusing or melting. You are getting a molten mass which is placed in distilled water, and you will get a solution. The solution is boiled and filtered. The filtrate is known as Lessein's extract or sodium fusion extract. 2 names. Here the most important point is, please write that point. Lysines extract is basic in nature. As some sodium metal react with water and form NaOH. It's a very, very important point. The nature of lysines extract is basic. Why it is basic? Because the sodium metal, when you are fusing with the sodium metal and just boiling with water, some sodium metal react with water and form NaOH. That's why it is basic or alkaline in nature. Next, the reason for fusing the organic compound with the sodium metal the reason for fusing the organic compound with the sodium metal is to, you take a pause. Actually, this is a very important question. They used to ask in the IAST interviews, KVPY interview question, this one. Very important. Why we have to heat or melt the given organic sample with the sodium metal. So here the answer is to convert the water insoluble covalent compounds into water soluble ionic compounds. To convert the water insoluble covalent compounds into water soluble ionic compounds. Because whenever these elements, for example, the carbon chain contains halogen, or the carbon chain contains sulfur. Sulfur can be directly present like O. What is the first compound? 1-chloropropane, a haloalkane. What is the second compound? Diethyl thioether. In the place of S, if O is there, ether. Whenever O is replaced by S, we have to use the prefix thio. It is thioether, second compound. Diethyl thioether. If there is O in the place of S, we call diethyl ether. It is called diethyl thioether. The next compound, if it is OH group, we call ethyl alcohol. It is called ethyl thioalcohol. This ethyl thioalcohol is also called ethyl mercaptant. Ethyl thioalcohol or ethyl mercaptant. What is one of the daily application of ethyl mercaptant? You might have studied in your CBSE syllabus, 8th or 9th class, about ethyl mercaptant or ethyl thioalcohol. So actually, the gas cylinder we are using for our domestic purpose, LPG. LPG contains two major components, butane and isobutane. These are the two compounds present in LPG, liquefied petroleum gas. What is the first compound? Butane. What is the second compound? Isobutane or 2-methyl propane. Both butane and isobutane are odorless. They don't have any smell. If the gas cylinder, the LPG, we are using without any odor, if any gas leakage occurs, we can't notice any smell because both are odorless gases. That's why the oil companies, whether you purchase a Hindustan Petroleum Gas, HP Gas, or Bharat Petroleum, any oil companies, any brand company, while sending the cylinder to your home, in the filling station itself, the butane and isobutane both are odorless. That's why they add a smelling agent. The smelling agent is ethyl mercaptant. Smelling agent in LPG. So what is the smelling agent in LPG? Liquefied petroleum gas. Both butane and isobutane are the major constituents. Both are odorless. To detect the gas leakage, we have to notice some smell. That's why they add a smelling agent. That is ethyl mercaptant or ethyl thioalcohol. So generally people, when they go for vacation, they lock the door, they close all the windows, kitchen windows, doors, everything they close, go for 10 days, 15 days vacation, they come back. Actually what generally the mistake they do, they don't switch off at the regulator. They simply turn off the burner switches. So from regulator pipe, the gas comes till the gas burners. Any rats or someone will bite that pipe, rubber pipe, gas leakage occurs. Or if the pipe is too old also, due to pressure, gas leakages. So the entire kitchen is filled with LPG. And people after coming from holidays, they open their doors and immediately they notice the smell. Because of methyl mercaptant, they notice the smell. The oil companies advise you, whenever you notice gas smell, you have to open all the windows and doors. That's all. You are very safe. Nothing, no panic, nothing will happen. But out of anxiety, what they do? They switch on the electric light or fan. When they just press the buttons, electrical switch, inside a small spark will produce. Switching of electrical appliances will produce a small spark. That small spark is enough to catch the fire. The entire gas enclosed in the room suddenly takes immediate fire. The entire room will be blasted. If the blast is so severe, all the people will lose their lives. It damages the surrounding buildings also. So it is very dangerous. So the first precaution, the oil companies advise you, first and the foremost precaution, whenever gas leakage is detected, simply open the doors and windows for 10-15 minutes. Gases have the property of diffusion. The LPG will diffuse outside. Outside air enters into this. It is being diluted. Nothing, no harm. Nothing will happen. Though no, people also know this, but out of fear and anxiety, their mindset goes to electrical switch. That became a catastrophic incident. So many people lose their lives in the gas leakage because of this. So I have mentioned 3 compounds here. Or you take ethyl cyanide or methyl cyanide. Or you take methylamine. So here Nitrogen is there, here halogen is there, here sulfur is there, here sulfur is there, nitrogen is there. So organic compounds containing nitrogen, halogen, sulfur. What bonds they are connected to carbon chain? They are connected by covalent bonds. So whenever these elements, what are those elements? Nitrogen, sulfur, halogens. When they are connected to carbon chain, by what bonds they are connected? Covalent bonds. Covalent molecules are water insoluble. That's why when you heat all these with sodium metal, sodium says, I am more electropositive, you are all more electronegative. So electropositive and electronegative combination give a water-soluble ionic compounds. So what is the purpose of Lessines extract? Why we are fusing with sodium metal is an important point to convert the water insoluble covalent compounds which I mentioned there into water soluble ionic compound. Now, in the detection of nitrogen, so in the detection of nitrogen, if N is present, in the given organic sample, so this N react with carbon and sodium metal and form sodium cyanide. This is the first step. The sodium cyanide is present in Lessines extract. So if at all nitrogen is present in a given organic compound, that will react with carbon and sodium metal and form sodium cyanide. In the second step, the sodium cyanide or this Lessines extract is treated with ferrous sulfate, freshly prepared ferrous sulfate. You will get sodium ferrocyanide, Na4FeCN6. What you will get? Sodium ferrocyanide. Like potassium ferrocyanide, K4FeCN6. Like that it is Na4FeCN6. In the last step, the sodium ferrocyanide react with ferric sulfate formed in the reaction. We don't add this, it is already formed in the reaction. This is occur in the presence of sulfuric acid. Now students require this last point only. You will get Fe4, FeCN6 thrice plus Na2SO4. It is called ferric ferrocyanide. This is deep blue or Prussian blue. So you need, it is only for knowing I wrote all the equations. But student precisely require what? If nitrogen is present, Lessines extract contain what? That point you require. Sodium cyanide. In the detection of nitrogen, the deep blue color or Prussian blue color is due to the formation of ferric ferrocyanide. These are the only 2 points you require for detecting nitrogen. Now I am going for sulfur. So over. Detection of sulfur. So if sulfur is present, in the given organic sample, sodium and sulfur react and form a water-soluble sodium sulfide. Present in the Lessines extract. So if the organic sample contains sulfur, when you fuse the compound with the sodium metal, so what water-soluble compound you are getting? Sodium sulfide, Na2S. Now this Na2S so Lessines extract containing Na2S is divided into 2 parts. For the first part, you add lead acetate. Lead acetate. Immediately you will get a black color lead sulfide precipitate. Plus 2CH3COONA. Divided into 2 parts. To the second part, we add sodium nitroprusside, Na2FeCN5 times NO. What is the name of this? Sodium nitroprusside. Dr. Ricky Ponting, sodium nitroprusside and brown ring complex, both I discussed in coordination compounds. Under what heading? We discussed both. Brown ring complex and also sodium nitroprusside. Both we discuss in coordination compounds. Because the NO group present in the complex is not a neutral molecule. It is nitrosonium ion, NO+. So just I want to recollect the thing. So this sodium nitroprusside, when it is treated with sodium nitroprusside, what you will get? A violet color addition compound called sodium thionitroprusside, which is violet color. It is called an addition compound because Na2 and Na2 are added to give Na4. FeCN 5 times. Sulfur is added to NO group, NOS. So this is detection of sulfur. Now, if X halogen is present, the given organic sample, then halogen react with sodium and form sodium halide, where X is equal to ClBrI. I did not write F because fluorine cannot be detected by Lessein's test. So in all the Lessein's tests, because we already mentioned Lessein's extract is basic in nature, first it is neutralized with an acid. In the detection of nitrogen, the Lessein's extract is neutralized with sulfuric acid. In the detection of sulfur, the Lessein's extract is neutralized with nitric acid. Here also, the Lessein's extract is neutralized with HNO3. That is common point. But you will get sodium halide. In the second step, this sodium halide, NaX, present in the Lessein's extract, react with the silver nitrate. So NaX react with AgNO3, forming AgX as a precipitate plus NaNO3. If X is equal to Cl, the precipitate will be AgCl, a white precipitate. If X is equal to Br, you will get AgBr precipitate, which is pale yellow. If X is equal to iodine, you will get a bright yellow precipitate of AgI. So very simple. You have taken Lessein's extract initially in big quantity. You take small and test for each one. In the detection of halogen, if at all the given compound contain halogen, what halogens? Chlorine, bromine and iodine only, not fluorine. So that we will discuss now itself. Why fluorine cannot be detected by Lessein's test. I already discussed in halogens family. Now again I repeat the same point now, because students cannot recollect long ago. Okay. So the sodium halide react with the silver nitrate and form a silver halide precipitate. If the halogen is chlorine, you will get a curdy white precipitate of silver chloride. If the halogen is bromine, you will get a pale yellow precipitate of AgBr. If the halogen is iodine, you will get a bright yellow precipitate of AgI. So here I write a point. Fluorine can't be detected by Lessein's test because F can't be detected by Lessein's test because AgF is water soluble. It do not form any precipitate. F cannot be detected by Lessein's test because AgF is water soluble and do not form any precipitate. So without any color, no precipitate is formed, you can't detect, because our heading is qualitative analysis. By qualities you have to analyze. Quality means the quality of the color, smell, solubility, some qualities. By seeing certain qualities, you are analyzing. By seeing the Prussian blue, that quality, you are saying it is nitrogen. By seeing the violet color with sodium nitroprusside, you are saying it is sulfur. Or by seeing the black color of lead sulfide with lead acetate, you are saying it is sulfur. So by colors, you are identifying. Color is a quality, correct? That's why the heading is qualitative analysis. Our heading is qualitative analysis. Now, if N and S are together present, right, next point. If nitrogen and sulfur are together present, in the given organic sample, so nitrogen, sulfur, sodium and carbon, all these react and form sodium thiocyanate. Sodium thiocyanate, a water-soluble compound. If N, S and NS are together present in the same sample, they react with the sodium metal along with carbon, because they are present in carbon compound, and form sodium thiocyanate present in the lysines extract. Present in the lysines extract. They ask this as a question. If N and S are together present, which compound is present in lysines extract? Your answer is NaSCN, sodium thiocyanate. Now the sodium thiocyanate, NaSCN, is treated with ferric chloride, FeCl3. And you will get a blood red color ferric thiocyanate. Blood red color. Ferric thiocyanate plus NaCl. You write 3 moles here, 3 NaCl. So what is the name of FeSCN thrice? Ferric thiocyanate. This is detecting both N and S together. Now the next heading is detection of phosphorus. Detection of phosphorus. So actually in the detection of phosphorus, we don't use lysines extract, we directly take the sample. Given sample plus sodium peroxide. Write the first point. Given sample plus sodium peroxide, Na2O2. Arrow. Phosphorus is oxidized to sodium phosphate. Phosphorus is oxidized to Na3PO4, sodium phosphate. This is step 1. Step 2. This Na3PO4 is treated with concentrated nitric acid to convert into H3PO4, phosphoric acid. In the last step, the phosphoric acid, H3PO4, is treated with ammonium molybdate, NH4 twice, MoO4, in the presence of HNO3. What is the name of this? Ammonium molybdate. Immediately you will get a bright color, bright yellow color. Ammonium phosphomolybdate, bright yellow. Color ammonium phosphomolybdate. The name of this compound is ammonium phosphomolybdate. This is detection of phosphorus. So all are important, don't take it light. So now I am moving. This is all over. Ferric ferrocyanide is over. Red estate, sodium nitroprusside, sodium ferric thiocyanate. Here. Write a note. If N and S are present along with halogens, if N and S are present along with halogens, the Lessons extract contains both Na2S and NaCN. The Lessons extract contain both Na2S and NaCN, which interfere in the detection of halogens with the silver nitrate. In the detection of halogens with silver nitrate. Full stop. They react with the silver nitrate and form white precipitate of silver cyanide, white PPT of AgCN, and black PPT of Ag2S. And a black precipitate of Ag2S. So once again I repeat, this is actually given in your NCERT textbook. So in the detection of halogens, what are the interfering elements? Nitrogen and sulfur, they interfere in the detection of halogens in the Lessines extract. When you add AgNO3, actually halogens react with AgNO3 and form AgX precipitate. Along with AgX precipitate, you may get an AgCN precipitate, a white color, and you may get Ag2S, a black precipitate. That's why you have to eliminate them. So that's why they should be eliminated, which is possible by heating or boiling with HNO3. So write one more point, hence they should be eliminated, which is possible by boiling with concentrated nitric acid. Okay, please write next heading, quantitative analysis. Quantitative analysis. So actually in quantitative analysis, we estimate how much element is present in the given sample or how much percentage of a particular element is present in a given sample. Quantity. The name itself indicates quantity. So in quantitative analysis, we don't see the qualities, color, smell or odor or precipitate. We don't see all these. Only we are concerned about how much quantity is present in a given sample or percentage. Both we can do. So in the quantitative analysis, the first rating is estimation of carbon and hydrogen. Estimation of C and H within brackets by Liebig's method. LEI or Liebig's. LEIBIG apostrophe S. Liebig's method. So in Liebig's method, we are going to estimate both carbon and hydrogen in one shot. Very simple. The given sample is heated with cupric oxide. Oh, it is already there. So C plus CuO, these two you already wrote. Same thing you repeat. The given amount of sample is heated with cupric oxide. C is converted into carbon dioxide. Hydrogen is converted into water vapor. Point number 2. The formed CO2 is absorbed. In a known weight of aqueous KOH solution. the CO2 formed is absorbed in a known weight of aqueous KOH solution. The increase in weight of KOH, solution is equal to the weight of CO2 formed. So the increase in weight of KOH solution is equal to the weight of CO2 formed. Let it be X grams. Let it be X grams. So your job is done for carbon. So here, weight of the given organic sample, weight of the sample is equal to W grams. Weight of CO2 formed is equal to X grams. How you determine the CO2 weight? The CO2 is passed into KOH solution of known weight. So when CO2 is absorbed by KOH, its weight will increase. It forms K2CO3 plus H2O. So what happens when CO2 absorbs, KOH absorbs CO2? The solution weight will increase. Already its weight is known for us. So whatever the extra increase in weight, that is equal to CO2 weight formed. That is X grams. So now you know 44 grams of CO2 contains 12 grams of carbon. Some X grams of CO2 contain how much C? So X into 12 by 44 grams of C. This is present in W gram of the sample. W gram of the sample contain this much carbon. Now 100 gram of the sample contain how much? So that is equal to X into 12 by 44 into 100 by W. This gives percentage of C. Students should know this last point. All this nonsense you don't require. Because that only to understand. But precisely you require the last point. Percentage of C is equal to X into 12 by 44 into 100 by W. What is X here? Weight of CO2 formed. In the last formula, X is equal to weight of CO2 formed. What is W? Weight of the given sample. Now similarly, percentage of C is over. Percentage of H. For that what we do? Whatever the water vapor formed, the water vapor formed in the reaction 2H plus CuO gives rise to Cu plus H2O is absorbed in a known weight of anhydrous calcium chloride, increase in weight CaCl2 is equal to weight of water formed. Let it be some Y grams. So when you are heating the given sample with cupric oxide, whatever the hydrogen is present is converted into water vapor. This water vapor, what we are doing? We are absorbed in a known weight of calcium chloride, anhydrous calcium chloride. A U tube is packed with calcium chloride. The U tube is connected to the test tube. So whatever the water vapor is coming, that is directly absorbed in anhydrous calcium chloride, whose weight is known to us. So whatever the extra weight, increased weight, that is equal to weight of water vapor formed. How much water vapor is formed? Y grams. Weight of the sample is W grams. Weight of the given sample is equal to W grams. Now from this you can do the calculation very easily. So I am erasing this. Done. So 18 grams of water, which is the molecular weight of water, contains 2 grams of H. But here we got Y grams of water vapor. Contain how much? So it is Y into 2 by 18 gram of H. Present in how much sample? W gram of the sample. But if we take 100 gram of the sample, how much? That gives percentage H is equal to Y into 2 by 18 into 100 by W. Students should know this last point. What is Y here? Weight of water vapor formed. What is W? Weight of the organic sample. And our next heading is estimation of nitrogen. Carbon hydrogen is over. The method we are calling as Liebig's method or Liebig's method. Now our heading is estimation of nitrogen. So in the estimation of nitrogen, we have two methods. One is called Dumas method. The next method is Geldahl's method. Is heated with cupric oxide and red hot copper. We are not only heating with cupric oxide plus red hot copper. So next point, nitrogen is first converted into oxides of nitrogen. N is first converted into oxides of nitrogen, which are reduced by red hot copper, to free nitrogen, N2. Point number 3. The gases are collected, the gases are passed into KOH solution. The gases are passed into KOH solution, which absorbs both CO2 and water. And nitrogen is collected over KOH. And N2 is collected over KOH. So your job is done. Experiment is over. So what is the experiment? The known weight of W gram of the sample. What we are doing? We are heating with cupric oxide followed by red hot copper spiral. So N will be first oxidized to oxides of nitrogen. Carbon is oxidized to carbon dioxide. Hydrogen is oxidized to water. So many things are formed, but these are again passed over red hot copper. Only oxides of nitrogen are converted into free nitrogen. So free nitrogen is there now, water vapor is there, CO2 is there. All these are passed into KOH solution. KOH solution, water dissolves, CO2 absorbs. Only left is free nitrogen that is collected over KOH solution. So your job is done. Only we have to do calculations. So write the heading calculations. Weight of the given sample is equal to W grams. Weight of the given sample is equal to W grams. Volume of N2 collected over KOH solution at room temperature is equal to V1 ml. Pressure of N2 gas is equal to P total minus P water vapor or P total minus aqueous tension that is equal to P1 mm of Hg. Room temperature is equal to T1 degree centigrade, that is T1 plus 273, that is equal to capital T1 Kelvin. So here a little bit annoying factor is, what is this aqueous tension and all this stuff? That is only you should have a little idea, because you already studied it, but maybe in your passive memory. Whenever a gas is collected over a liquid, here N2 is collected over KOH solution. KOH solution contains some water. The water also becomes water vapor. So whatever the pressure that you are measuring is not the pressure of nitrogen alone. It is the pressure of nitrogen plus pressure of water vapor. It is combined pressure. That is called P total. So pressure of nitrogen is, from the P total, you have to subtract something. You have to subtract the water vapor pressure. So that's why pressure of nitrogen gas, what I wrote, P total minus PH2O vapor. Partial pressure of water vapor is known as aqueous tension. So that's why in the next column, next line, what I mentioned, pressure of nitrogen is equal to P total minus aqueous tension. What is aqueous tension? Partial pressure of water vapor. Here V means water vapor. So partial pressure of water vapor is known with a new term called aqueous tension. How do you know aqueous tension? Scientists already calculated aqueous tensions, partial pressure of water vapor at different temperatures, and they give a chart. So a standard chart will be in the laboratory. Today's temperature you have to note and see what is the aqueous tension. So from a total pressure, you subtract aqueous tension, you will get pressure of nitrogen gas alone. That is P1 mm of Hg. So by using gas equation of state, by using equation of state, what is equation of state? P1 V1 by T1 is equal to P2 V2 by T2. We convert the volume of N2 from room temperature. These are at room conditions. This is lab conditions. These are STP conditions. We are using equation of state P1 V1 by T1 is equal to P2 V2 by T2. What is P1 V1 by T1? It is the conditions at laboratory conditions or room temperature conditions. What is P2 V2 by T2? STP conditions. Already you know how much volume of N2 collected. V1 you know. You already know P1. You already know T1. You know at STP, P2 is equal to 1 atmosphere, that is equal to 760 mm of Hg. At STP T2 you know 273 Kelvin. At STP V2 you don't know, question mark. So out of the 6 quantities, how many quantities you know? Only one unknown quantity is V2. So here V2 is equal to P1 V1 T2 by P2 T1. Let's say this is XML you got. That XML is volume of N2 at STP. Write that point. The XML is volume of N2 at STP. Or in a nutshell, you know already volume of nitrogen collected at room temperature. This volume is converted into STP conditions. What is the volume of N2 collected at laboratory or room temperature? V1 ml. What is V2 volume at STP condition? So we converted V1 into STP conditions. How much we got? XML. Now, so I am erasing this. Okay. Now you know 22,400 ml of N2 at STP weighs is equal to its gram molecular weight, 28 grams. XML of N2 at STP weighs how much? So X into 28 by 22,400 gram of nitrogen. If you want percentage of nitrogen, the same fraction is multiplied with 100 by W. That is common. In the previous we have discussed that point. Into 100 by W. So students only should know this point. Students should know only 2 points in Jumas method. 2 or maximum 3. So what students should know? In Jumas method, nitrogen is estimated in the form of free nitrogen, N2. You should know that point. In Jumas method, nitrogen is estimated in which form? In the form of free nitrogen. The second point, percentage of nitrogen is equal to X into 28 by 22,400 into 100 by W. What is X here? Volume of N2 at STP. X is equal to volume of N2 at STP. W is equal to the given weight of organic sample. So your job is over. Percentage of nitrogen by Jumas method. Now we are going for Geldahl's method. In Geldahl's method, the first point, the given weight of organic sample within bracket W grams, the given weight of organic sample within brackets W grams is heated with concentrated sulfuric acid. Is heated with concentrated sulfuric acid. N is converted into ammonium sulfate. This you should know. Nitrogen is converted into ammonium sulfate. Next, in the second step, this is first step. This ammonium sulfate is treated with NaOH. So that ammonia gas is liberated. plus Na2SO4. Point number 3. The liberated ammonia is passed into standard H2SO4 of excess volume. This is the third step. What is the meaning of standard here? Standard means, write in the bracket, standard means its concentration is known to us. Its molarity or normality is known to us. So whenever you use a standard acid means it's an acid with a known concentration. Concentration is usually expressed in molarity or normality or molality. Any term you can use.